how can you solve the system of inequalities? So we have these inequalities here. Y is smaller than x squared plus 2x minus 3. And if you are plugging in the decimals, you get this graph of the function, this a parabola in this way. But because it says smaller, so we are not including the border. That's why the border is with a dash, with the dashes. And the other linear equation is y is greater than x minus 1. So again, we have x minus 1 is this line here, linear equation, and y is greater. It means the solution is on the upper side, in this side here. But y is smaller than x squared plus 2x. It means it takes everything down from this part here. And if we look at the solution, is solution whenever they intersect with each other. The solution is here. So this is the solution. Here is the solution. And this region is solution. This is a not solution. That's why I'm saying, I'm writing with the n. And this is not solution. But solution is not the border, does not include in the solution of this system of linear equations. This system of inequalities does not include those borders, but just as this region here is a solution, and this region here. So x is from 1 to infinity, but does not include 1, and from negative infinity to minus 2. If we want this little bit to look from the perspective how we can graph it them, when we have y smaller than x squared plus 2x minus 3, we can graph like we graph in the quadratic equation. But here, for instance, let's say this is a y is smaller than x squared plus 2x minus 3. And I want to solve, for example, or I want, first of all, this to convert into the completing square, because it's much easier than to take information and to graph it to the quadratic function or inequality. So plus 3 I'm going in both sides. If I am adding both sides plus 3, this equation here is going to look this way: x squared plus 2x. X squared plus 2x. And I'm taking a little shortcut because we already showed how we can we already show how we can graph and how we can convert into the completing square. And this b is a 2 divided by 2 is 1 square. So 1 square is 1, and if I'm adding 1 both sides, then this equation is going to be x plus 4. So I'm taking a shortcut, I'm not going in every detail. Is smaller than x squared plus 2x plus 1. And now x squared plus 2x plus 1, we already know this is a squared trinomial. And because this is a squared trinomial, we can write in this form: x plus 1 square. X plus 1 square. And this is I want just a y in relationship with the axis, how it can be. Negative 4 both sides. If I'm putting negative 4, plus 4 is a 0, and in this side is negative 4. So now already I have this function in the vertex form. And because it's in the vertex form, I already know if I have a quadratic parent function, x squared, this is going 1 unit to the left and it's going 4 units down. So the vertex here is a negative 1 and is 4. So we got the vertex. And now to get, for example, those points of intersection. Point of intersection, we don't have to use a inequality sign. We can use those equal sign. For example, y is equal with y. This y is equal with this y here. like we are solving linear equations. How, in the same way, how we can find those, how we can find, for example, the solution in linear quadratic systems is in the same way. And here, what do we have here? Instead, it's x squared plus 2x plus 2x minus 3 is equal with x minus 1. If I am subtracting both sides by x minus 1 minus x plus 1 both sides, no, I know for sure this is going to be 0, because minus x plus x is 0, minus 1 plus 1 is 0. And the other side, x squared, is not going to affect x squared, but is going to affect the plus 2x minus x is a plus x. And plus 1 minus 3 is minus 2. And if we are factorizing this now, is going to be x plus 2x minus 1. X plus 2, x minus 1 is equal to 0. And from here is obvious. So x is equal to minus 2. Just let me write it with a different color. X is equal to minus 2. From this factor, we know x plus 2 is opposite side. X is equal to minus 2. If we solve x plus 2 equal to 0, x is going to be equal to minus 2. And in the other factor, x minus 1, we get in the solution x is equal to 1. So we already, those intersection points, we have here, this point here, this point here we have, and this point here. Already we have 1 and minus 2 x's. So the solution. But if we want to, for example, in what interval is the solution, here is in the interval the solution. The solution is here, is from minus infinity. The solution is from minus infinity to minus 2. From the solution from minus infinity to minus 2, but does not include the minus 2. That's why I am taking this parenthesis. And the other interval of the solution is from 1 to infinity. Is from 1 to infinity. It does not include 1. And that's why I'm writing here. Or you can write it with those intervals. Here, for example, the solution is from minus 2. I'm sorry, from minus infinity. Let me write with a different color. From minus infinity to minus 2. Or is from 1, x is a greater, x is greater than 1, and is smaller than infinity. So here is the x.